Hey everyone, welcome back. On today's video, we're going to talk air conditioning. We're going to talk about signs if it's running good. We're talking about signs if it's not running good. We are going to go over some basic maintenance, some things you can do yourself to help keep your system running well. And then at the end, we're going to go over some troubleshooting to help you troubleshoot if your system's not working at all. Obviously, the first sign if it's running good, cold air coming out your vents, right? That's a simple one. Let's go on to the next one. And the second most common sign that it's running good is something I do pretty much every time I'm outside and I hear the AC turned on. Simply walk by and run your hand across the top of that fan. You should have nice warm air coming off of it. It should be coming up in a straight upwards position, maybe blowing slightly sideways. The third easiest test and the quickest is basically to come out here to your line set. Obviously we got two lines. We got a large suction line covering insulation, and you got a smaller line, usually about a 3/8, and this one's hot. Try not to touch that one, it will burn you. This one up here is insulated for a reason. If you slide that insulation back and grab a hold of that line, if that line's as cold as you like your beer, it's usually a good sign it's running good. Put the insulation back on when you're done though. And the last test is the most important one. This you don't have to do every day, but if you question if your AC is running good or not, the simple test is basically what we call a temperature drop across the coil. Sounds complicated? It's not. What we're going to do today is basically a digital meat thermometer. Nothing special. Bought it at Menards, $9.99, right? Here's what we do. So I realize that every system's different, but they all have a basic design. We're going to go into, we're out here in my shop today, obviously. And we're going to go to my filter on my furnace. And we're simply going to take our thermometer, we're going to slide up into the filter area. Anywhere around your filter is fine. And we're just going to check that temperature. And then we're going to record it. So we're at the filter. I had about 74-degree air temperature. So that's the incoming air into my furnace or my air handler. Now this is, obviously it's in my shop, and this is what we call an upflow unit. Basically the filter is on the bottom. Yours might be on the side, same concept. The air gets drawn in from the bottom, goes up through the heat exchanger, goes up through the A coil of the air conditioner, and then goes up the plenum and into your ductwork, which goes out throughout your house. Like I said, this is an upflow unit. If you live in a mobile home, that might be a downflow unit. Return air comes in the top, goes down through the furnace, down through the A coil, and then out to your ductwork. So it's up to you to figure out what system you have, but they're all the same concept. We're going to measure the return air temperature at the filter, which we did already at 74 degrees. Now we're going to go up here and we're going to measure the outcoming air temperature at the plenum. We're not going to do it right above the A coil. We're going to use, I like to go up to the first takeoff where the ductwork connects to the plenum. And that, by going up about 4 foot, you're going to get an accurate measurement. So let's do that. So here at the first takeoff on my plenum, I know that there's an access right here in this corner that I left when I installed it. And if not, you can simply just drill a small hole or poke a hole in it with something. You don't want to do it down here at the A coil because you don't want to damage that coil. That's why we're going to go up here a good 4 foot at the takeoff, and we know there's nothing up here that's going to hurt anything. So now we're going to let it temperature settle, and then we're going to do some math. So as you can see on the thermometer, we're at about 56.5 degrees temperature coming out of the plenum. So with a 74-degree incoming temperature and a 56-degree outgoing temperature from the plenum, simple math tells us we have an 18-degree temperature drop across the A coil. Anything around 19 degrees is a good number. If you're down around 13 or 14 degrees or even less, that's obviously your AC is running, but it is not running as well as it could. So that's telling you that you have an issue. Now we got to find the issue. So now let's talk signs that the unit's not running good. First sign that your AC is not running good is either a low cool or a no cool. Low cool basically saying it's cooling, but it's not keeping up. The thermostat's not getting satisfied by temperature drop, or the AC seems to be running for long periods of time. Obviously that's your first sign we have an issue. The second sign that an AC is going to show you is an ice buildup anywhere on the unit, anywhere on the plenum, anywhere on the line sets, or anywhere on the outdoor unit. Ice buildup anywhere on the system can be attributed to two situations. The first situation, and the most common, is poor airflow across the indoor coil. Mainly, your filter's plugged. If it's not a filter, it could also be that your return air registers inside your home are blocked with furniture or blocked with clothing. If there's no signs of an airflow blockage anywhere in the system, then the next most common issue is low on charge, which obviously you're not going to be able to remedy without a service call. The third sign that the system's not running good is condensation on the floor, whether it be from the condensate drain or from the A-coil itself. So if there's water on the floor, it could be from the A-coil freezing up, again, from poor airflow, or B, most common, is a plugged condensate drain. All air conditioning systems are going to have a drain to drain the excess condensation away from the system. Most commonly, these will get plugged up either at the elbow coming straight out of the unit, or most common is in the P-trap area in this section right here. A plugged condensate is easy to repair, but usually requires opening the system up. Now this section here is just CPVC pipe, which is common in most installations. Some just use standard PVC, some use a clear plastic hose coming out. Every house is going to be different. But in this system, this is hard plumbed with CPVC. So in order to access this and clean it out, we're going to have to break this pipe somewhere. Now this is just standard pipe that we can get from any big box store, so the repair is fairly simple. We're going to go through and cut it somewhere close to this elbow right here. So when we cut this line, which you can always see a coupling here, we're going to cut this line, which is going to allow us to unscrew this fitting out of here and check this system here to make sure it's clear. After that's also cut there, that's going to allow us to remove the condensate system and blow air or water down through it and clean out the P-trap area. The condensation trap in this situation is the most common area for a backup to start. By this being plugged with gunk internally, it allows the water to back up all the way back into the A-coil and then overflow internally, which obviously is going to run down through the furnace and out the bottom of the furnace itself. So as you can see on my system, I installed a clean out cap right here at the top of the trap. That way if this does get filled up with crap, I can simply just pull this cap off, flush the system out, put the cap back on, it's good to go. The third situation, if you have water on the floor, is if you have a condensate pump in your system. Not all systems have it, they're only used in certain installations basically. But if you have a condensate pump, it's usually located on the floor, a little box, and the condensate runs into it. If internally that thing gets full of gunk, which it does, or the pump fails, again, it happens, the condensate is obviously going to back up and overflow out of it onto the floor. Now a lot of condensate pumps do have a float switch internally that runs through the control circuit of the furnace or the air conditioner. And if that pump basically gets full and is not turning on, the float inside will actually shut off your air conditioner or your furnace, depending on how your installer wired it. It's one thing to always look at. So now we're back outside, and we're going to show you a few things to look for on the outdoor unit on a normal basis. Anytime you're walking around the yard, cutting the grass, things like that, if the AC is running, here's a few things to check. First and foremost is the cleanliness of the outdoor coil. Again, airflow is extremely important in an air conditioning system to make this thing run correctly. It needs airflow across this coil. It cannot be blocked with shrubbery or trees or weeds, anything like that. The other thing to look at is just basically build up on the coil itself. If you live in the Midwest and you deal with cottonwood trees and stuff like that, you know what we're talking about. The other thing is that when you're cutting the grass, try not to blow the grass directly at the air conditioner, especially when it's running. I always cut away from the air conditioner on both units. So with a quick glance, I can pretty much look right at my AC unit and see the tubes running through the coil. I can see the fins are clean and straight, they're not bent, there's no buildup on the system, so everything's good that way. Now back to our airflow coming out the top of this unit. Right now it's not running, obviously, so we can talk, but under normal running conditions, the airflow pretty much comes straight up, maybe at a slight angle away from the unit. If you ever experience it where the air is coming out at like a 90-degree angle off of the unit and it is extremely hot, that is a sure sign that your coil is plugged and the fan is not able to move air through the coil and remove the heat. Now keep in mind, if we can't remove the heat from the coil, we can't remove the heat from your house. So now let's talk about some basic maintenance and things you can do to keep the system running well. First and foremost, the air filter. This is very important in an air conditioning system to keep clean. You have to check it, at least check it once a month. If it's extremely dirty at once a month, check it every 2 weeks. Dogs, cats, all that good stuff, they wreak havoc on a filter. Number two, filter quality. Don't buy the cheapest ones on the market. Simple thing to look at here is all filters have what they call a MERV rating, M-E-R-V. This is a MERV rating of 8. Anything from like a 8 to a 13 is a good filter. Anything over 13 is more for like hospital use and stuff like that. Anything under like a 6 or a 7 or less is not really going to filter the air. The object of a filter is to collect the dirt before it gets trapped in your A coil. Once that's in your A coil, well, then you got a service call. And the other most important thing you can do to keep your system running good is to take care of this unit out here. Make sure there's no vegetation growing around it. Make sure the bushes aren't growing up against it. Make sure you didn't build a deck directly over top of it, because I've already seen that. Don't do that. This thing needs airflow, and it needs airflow on all sides. That's why it's placed a distance away from the building. And the other third place that this thing is going to get dirty is between the building and the unit. That's the coil that will most likely get dirty first. Now, if you live in the Midwest like we do, and you have the cottonwood flying all over the air in the springtime, it's going to be natural for it to get sucked right into this air conditioner and build up a nice layer of cotton right across the front of this machine. If you stay on top of it, it's easy to remove. The easiest way to do that is simply with a water hose. But first, pull the disconnect and shut the unit off. If you don't have a disconnect outside, go to the main breaker, shut the breaker off. You don't necessarily want to be spraying water into this unit when it's running. I understand it does get wet in the rain, but rain comes down on the system. It doesn't blow into the system. If you get this fan motor wet from the bottom, you're going to kill it. So after you shut the power off to the unit, it's very simple. Just take a water hose with a sprayer, medium pressure, don't get crazy, and all you have to do is side to side, wash the unit down, get all the gunk to the bottom, and then try to spray it out the best you can. Alright, so now we got all the basics out of the way. Let's talk troubleshooting. Let's go through the basic scenario, because you know what's going to happen on the hottest day of the year. It's probably going to be a Friday after 5. If you make a service call, you're going to be paying after hours bills, right? So worst case scenario, you come home, it's hot in the house. What do you do? Well, first things first, we're going to check the thermostat. As we can see, it is lit up, so we know we got power. If you don't have any power or the screen's blank, obviously there's the start of an issue. Now the older units, they have batteries internally, and if those are dead, obviously you're going to have an issue. Take it off, change the batteries, Google it, whatever you got to do. Second thing, it's lit up, everything seems to be working. The set temperature is obviously not being satisfied, and it's hot in the house. So now that we verified the thermostat is in fact calling for cooling and it is not technically working, the system's not working, we need to go through and figure out who's working and who's not working. Now the thermostat is going to tell the furnace to turn the fan on, and it's also going to tell the outdoor unit to turn on also. So it's going to be doing 2 different tasks, and we need to figure out which one is actually working. Obviously the first one is easy. Check the furnace, see if the fan's blowing, make sure everything's working. Look for signs of ice, signs of water, anything out of the ordinary. And then go check your outdoor unit and see how the outdoor unit's going. Is it on? Is it not on? Is it making noise? Does it have ice buildup on it? And then we can kind of figure out which way we got to go. We're going to start this scenario inside the furnace. The furnace fan's not running, the outdoor unit's not running, nothing's running, but the thermostat's calling. So let's start there. So we're going to start our search here right at the furnace itself. So I've already got the front door taken off, as you can see, and basically my first check is there power going to my furnace itself. Now in this particular unit, I got a service light right down through this little glass screen right here. It's lit up orange. That tells me we at least have power to the unit. Now almost all furnaces installed in the last probably 30 years are mostly required by code to have a service disconnect within a few feet of the unit. It's usually just a light switch, usually mounted right on the side or real close to it. Obviously, check that first if you don't have power. It's easy for a kid to run through there and shut that switch off on accident. If the switch is on and you still see no signs of power, obviously go back to your fuse panel, check the breaker. Make sure the breaker's not tripped. If the breaker's tripped, well, then you got a whole other scenario, and it might be best just to get a service call going. But for this scenario, we're going to go with the fact that we have power at the unit, so now what, right? So what we're going to do now is we're going to remove the service panel, which is going to access the blower compartment. And behind the blower compartment is pretty much a circuit board. That's what that little light is. And that's where all of our thermostat wiring is going to be connected at. And that's what we need to get to next. On this unit, there's 2 5/16 screws, one at the top of each corner, and this panel is going to come off. Alright, so now we have our service panel removed, which is obviously giving us access to the blower and to the main board of the system. And right here on my system, and they're all fairly similar, but none of them are the same unless they're the same models, obviously. But this here is our thermostat wiring. You got 2 wires usually. You got a 5-conductor wire and usually a 2-conductor wire. I'll explain those in a minute. But the biggest thing that I need to point out first is this disconnect right here. As soon as I took this service door off, it opened this switch up. This is a safety switch, so now there is no power anywhere inside this furnace because it's shut off at that. So to do any of our checks, we're going to have to bypass this switch simply by holding it in or having somebody else hold it in or putting a piece of tape across it to hold it in. But basically we need to close this, and you can see now we got power back on. So I basically just bent this 2-conductor wire around, tucked it under the switch there. So now the switch is on, and now we can go through and make our checks for our thermostat wires and try to figure out what's going on. Now, the thing to know about a furnace is most furnaces have a transformer built into it. Ours is located right here behind the system. So that comes in, 110 volts comes into the transformer. The transformer is a step down transformer, so it steps the voltage down to 24 volts AC. And that's what our thermostat wires are running at. They're running at 24 volts. So what transformer sends 24 volts to the R terminal, and then either the C for common, or on my setup here it says common 24 volts. So basically if I measure voltage from the common to the R terminal, not the red wire, the R terminal, I should have 24 volts. So let's check that first. So obviously to check our voltages, we're going to need something to check the voltage with. Now obviously I have like a $400 fluke meter that I use for all my service calls and stuff like that. But to keep this simple, this is a very easy to access voltmeter. I think I got this at Walmart. I actually keep this in my boat in the glove box. I've already used it multiple times. It's a very simple system. Checks your AC voltage and your DC voltage, and it's actually labeled so you don't have to figure out what they mean. So with our meter, and we are set to AC voltage, ACV, you can see the V sign with the squiggly line above it. That means it's alternating current, which is AC voltage. So what we're going to do is we're going to check to make sure our transformer is in fact working correctly. So we're going to check power from the R terminal to the C or common terminal, depending on how it's labeled in your furnace. So we're going to put the red one on the R, the black one on common, and we're going to look for 27.2 volts. So that tells us that the transformer is in fact working. Now if we did not have voltage or 24 volts across the R and the C terminals, first thing I'm going to look at is this little 3 amp fuse right here. It's an automotive style fuse, and the job of that fuse is to protect the transformer in case something gets shorted out in the system, in the low voltage system. It's going to blow that fuse before it smokes our transformer. We'll get more into that when we get into the outdoor unit troubleshooting. But for this scenario, we have 24 volts across our R terminal and our C terminal. So now we need to move on to the next step. So the next step we have to go to is we need to figure out if the thermostat is in fact telling the furnace to run and the air conditioning to run. And what we're going to do to verify that is checking our voltages again at these terminals. This is where our thermostat wiring comes in and tells the system what to do. So the red wire that is connected to R most commonly is red. It's supposed to be red, but it doesn't have to be. It's all dependent on how your installer wired your system. But the standard in the industry is R is obviously red, and that is sending 24 volts to our thermostat through this through this thermostat wire right here. So this goes over to the house and onto the wall into the thermostat. So 24 volts going out of the R to the thermostat. And then depending on what your thermostat is telling the furnace to do, it sends power back down certain wires. All right, so back at the control board here, the thermostat is wired into the system like we talked about, and each wire is designated. On the board are W's, Y's, G's, they're all letters, okay, and they all mean something. Usually the color of the wire is coordinated with the terminal. For instance, this one is Y1 and it is yellow. But again, it does not have to be yellow. It's all depends on how your installer wired it. So you need to go to the board and look at the board, and those are the terminals we need to check, and I'll tell you which ones we need to check. So looking across the board here, I have W1 and I have W2. W is white wire and it's for heating, okay? W1 is first stage of heat, W2 is second stage of heat if you have a two-stage furnace. So that's not what we're looking for. When the thermostat calls for cooling, it's going to do two things. It's going to send 24 volts down the G wire, which is green if it's labeled correctly, but it's the G terminal, and that is to tell the fan in the furnace to turn on. So we need to check 24 volts from common to green and see how that is. So again, with our meter set to AC voltage, we're going to use the black lead, and we're going to go to the common. This is difficult to do while trying to show it on camera. So we got the common, and then we're going to check the red one to the green wire, which is the fan on. And as you can see, we've got no voltage, 0.133 volts. So the thermostat is not telling the fan to turn on. So now, what about the air conditioning? Let's check that. Again, we're going to go from the C terminal, and now air conditioning is always Y1. We have Y1 and we have Y2, same thing. We have first stage of cooling, which is Y1, and we have second stage of cooling, which is Y2. There's nothing hooked to Y2, so we're not going to worry about it. So with that being said, Y1 is our first stage of cooling, so that's where our voltage should be, because the thermostat is now telling the air conditioning to turn on. So we're going to check from common with our black lead again, and then we're going to check to Y1. Well, let me turn this thing around so you can see it. Y1, what do we got? No voltage, 0.052. That is not 24 volts. That's 0.052. So again, there's no voltage there. So by checking voltage from the R terminal to the C or common terminal, and we had 24 volts, 27, but 24 volts, that verified that we're sending power to the thermostat. But because we checked power from the common to G, which is the green wire, which is the command to tell the fan to turn on, there was no voltage. That means the thermostat is not telling the fan to turn on. And then there was no voltage from the common to Y1 terminal, which is yellow, usually. That was telling me that the thermostat is not commanding the air conditioner to turn on also. So basically, in that scenario, there's either a break in the wire between the furnace and the thermostat, or the thermostat's bad. Now, quick easy way to check that is if you take any kind of a jumper wire and jump from the R terminal to the G terminal, the fan will turn on. So if you followed those tests and you have decided that your thermostat is in fact bad, it's simple. Just head to Menards or Lowe's or whatever the big box stores are, pick up a new thermostat, bring it home, shut the power off to your furnace. At the switch or at the breaker panel, shut the power off. Simply remove your thermostat off the wall, replace it, follow the directions, best you can do. All right, so now let's run off the most common scenario. You come home, the AC's, it's hot in the house, the fan is in fact running in the indoor unit, the filter's fine, no signs of trouble, so you come outside and nothing. The outdoor unit is not running. This is the most common scenario in an HVAC service call. So we're going to go over the basics of what you can do to try to get through this problem. Now if you come out to the unit and you hear a slight buzzing coming from inside the unit, very low buzzing, but nothing is turning on, that's telling me that the contactor is in fact closed and it's calling for the cooling to be running. So the problem is usually the high voltage, which is 220 volts. And if you're not comfortable with high voltage or electricity, stop right here, call a technician, and let them handle it. But if you're comfortable dealing that electricity, well, then we're going to dig a little deeper. So first things first, let's just check our voltage, make sure we got power coming out here. Easiest thing first, check the breaker inside, make sure the outdoor 220 breaker is on or not tripped anyways. If that's good, we're going to come out here to our service disconnect, pretty much open that up nice and easy. I know it's hard to see. We're going to go and we're going to check our disconnect. We'll pull this out, knock that down. So there's our service disconnect. We're going to get that out of the way for now. And now we're going to go into these terminals with our voltmeter set to AC voltage, and we are going to check for 220 volts across two of these terminals. So with the inside safety cover removed from my disconnect box, you can see the 4 wires up here. 2 wires are obviously the voltage coming from the fuse panel inside the house, and the other 2, which are the outer wires, are what goes to the AC unit. And right here it says line and line. So those are our lines coming from the fuse panel. So what we're going to do is we're going to check our voltage across those 2. So again, using our handy dandy Walmart special voltmeter here, I think this was like $24 or something. It's pretty handy to have around. We're going to check our voltage to the 2 inner lines that say line on them, and we're looking for 220 to 240 volts. And we got 241 volts. Now if you had 0 there, then we would check from our neutral or common, or not common, I'm sorry, ground in the center to each terminal individually, and we should have 110 volts on each line. So put in the black on ground, and then come up here and check our voltage to this line, 121 volts. Check this line, 121 volts. Combination of the 2, 240 volts. If we only had 110 on one line, on one leg, and not on the other, then we're going to go backwards into the breaker panel, because obviously we're having an issue there. So basically we got voltage coming here, so we're going to put this back together. We're going to put our service disconnect back in, and then we're going to go into the unit. Obviously everything's working good here. So again, scenario, the indoor unit's running, the outdoor unit is not. So now we're going to go into our service panel. We've already verified that we do have 220 volts coming into the disconnect box. The disconnect box is now back together. Behind this panel, again, every air conditioner is different, but at the end of the day it's pretty much the same concept. Just got to figure out which way yours is set up. So we're going to carefully, because we got high voltage in here, and again, if you're not comfortable playing with high voltage, call a technician, stop right here. I'm not concerned with it. Alright, this is the inside of an old air conditioner that works really well. That's why we haven't replaced it. So it's pretty simple what you have in here. We have obviously the AC compressor. We have the condenser fan located up here. We have what they call the run cap right here. It can be a start cap and it can be a run cap, or it can be a combination of 2. This is a combination capacitor, so it runs the it runs the AC compressor, and it also runs the fan. We'll get more into this in a little bit. So now we're going to check, like I said, the unit's not turning on. So once we're inside the unit, we need to verify where our voltage problem stops at. So we have 24 volts coming in from our thermostat. Right here are my connections. Every unit's going to have a connection somewhere in it where our thermostat wire coming from the thermostat into the AC unit is going to send 24 volts through the control circuit, which in my situation, I have a high pressure switch and I have a low pressure switch. So basically 24 volts is going in and out of that switch, in and out of this switch, and if both those switches are happy, then it's going to continue to send power up here to our main contactor. Now this is the main contactor that controls turning on the fan and the compressor. You got 240 volts coming in on one side, and then when the contactor closes, it sends 240 volts out the other side, which is obviously going to tell everybody to turn on. This is where most of our problems show up on a service call, right here at the contactor. So we got 2 scenarios. If you have 24 volts across the coil, the control circuit, at these terminals, 24 volts, and the contactor is not closing, that is telling us that the contactor is bad internally, and the coil is open, so therefore it cannot close the contact. If you do not have 24 volts across these 2 coil wires, that's telling us that we have a problem in our control circuit. So now we need to go backwards and check these switches here. Now on my system, these are automatic reset switches. So if it trips on high pressure, when the pressure resolves, it'll close back. Same thing with the low pressure. Some high pressure switches have a mechanical button you need to actually manually reset. These are automatic resets, so again, we know that's not the situation. Most common problems is the contactor failing. Second scenario are bugs. What happens is, especially around the Midwest here with our box elder bugs, they are attracted to the heat and the vibration of that contactor buzzing when the machine is actually running. So they'll basically hoard up around that thing, and what happens is it'll shut off, and then somebody gets curious and they crawl through into the contactor, and then the air conditioning calls, slams that contactor shut, pinches that dude between the contact points, and does not allow the power to transfer across the contact to actually turn the machine on. So by doing a visual inspection, you'll see it plain as day. If that is the case, which is most common, then you need to shut off your disconnect switch on the wall over there, make sure there's no power going to the unit. Then you need to take your voltmeter, verify that there is no voltage going to that unit anywhere, and then, and only then, can you try to fish him out of there. But if you're going to do it correctly, buy a new contactor, replace it. It is a wear item. It is going to fail. They do fail. The other side of it, if it's not a bug in there, the contact points can actually just be corroded. And again, not allowing power to transfer through the switch. If that's the case, again, replace the contactor. They're not expensive. They're easy to replace after you shut the power off to the unit. That's shutting off the furnace and shutting off the main breaker for the air conditioning. Alright, so now let's get back to that little 3 amp fuse inside the furnace on the circuit board that we were talking about earlier. The job of that fuse is to protect the control circuit, which is 24 volts. If that fuse is blown, it's telling you that there's pretty much a short somewhere in your control circuit. Most likely, it's in the outdoor unit or on the way to the outdoor unit. Basically, you have a couple different scenarios. One, a mouse chewed through it, and it's actually shorting it out to ground or shorting it out to the other wire anywhere along the line. If you see that, obviously shut the furnace off, fix the short, replace the fuse, and verify that everything's working correctly after that. If you see no signs of animal damage anywhere, then the next best thing is to unhook the 24 volts from the contactor inside the AC. Disconnect both wires. Make sure they're insulated, meaning they're not touching ground or touching each other. If they're hanging in midair, that's fine, as long as they're not shorting to ground. At that point, replace the fuse and see if the fuse blows or not. If the fuse does not blow then you know that the problem is in the contactor. And it does happen. I've seen it on my own stuff here at the house one time. It does happen. If the fuse still blows, then you still have a problem and you need to keep digging until you find that short. It might even be in the board on the furnace. At that point, you're probably going to need a technician to come out, but 9 times out of 10, it's the contactor on the outside. As far as replacing the fuse, don't replace it with a bigger fuse. That's not the answer. It's a 3 amp fuse. It's there for a reason. Anything over that, if you put a 15 amp fuse in it just to get by and it shorts, it will literally blow the transformer up inside the furnace. Not like a big explosion, but it will blow up. It will pop. I've heard it. I've seen it. I've done it. All right, everybody. Third and final scenario. You come home, the house is warm, the indoor fan is running, so you come out here to check the outdoor unit, and it's trying to run, which means the fan is trying to start, or the compressor is trying to start, but it can't. If you run into that situation, 9 times out of 10, you're going to be dealing with the capacitor. This capacitor stores energy. So when the fan tries to turn on and when the compressor tries to turn on, it takes power from this capacitor and uses it to basically give it a kick in the butt to get the motor going from a dead stop. Once it's up and going, it's good from there. But this helps get it started. To replace this is easy, and if you see any signs of it leaking oil and stuff like that, it needs to be replaced. This one here was replaced, according to my notes that are written on here, it was replaced in 2017, and I do think I replaced this again since then. They do fail. The contactors fail, these fail. They're wear items. Anyways, this can be replaced easy enough by following the rules, okay? Rule number 1, make sure the power is off to this unit. This thing is storing electricity. You do not want to get hit by a cap. These things will set you on your butt. Make sure the power is turned off. Number 1, verify with your voltmeter, no power, no power. Make sure everything's shut off. I cannot stress that enough. Number 2, before you touch any of these wires, I don't care if the power is off, do not touch these wires. You need to discharge this cap. Like I said, this runs the fan and the compressor, so it might not be starting one, but the other side's still charged. So you need to discharge the capacitor. The proper way to do that is to basically take a metal screwdriver with an insulated handle, and you need to short the terminals between each other as much as you can. Short it, short it, short it, short it. Short the terminals to chassis ground, which is just metal. Short it, short it, short it. And even then, I never suggest grabbing a hold of these wires. I'll take a pair of insulated pliers, pull the wires off one by one, let them hang there nicely. Remember where they go, okay? One's power, one is Herm, which is compressor, and one is fan. Don't mix them up. These are rated. They have ratings on them. You have to replace it with the same rating that it has, okay? There are some cheats that you can do, but you need to know what you're doing if you're going to cheat. The easiest way to do it is find the exact same cap. This cap here is a 45 plus 5 MFD, give or take 5%, okay? It needs to be replaced with that same number. And there's a voltage rating on it also here somewhere. Right here, 440, 370 volts AC. All these numbers mean something. So you got to find the capacitor that matches those numbers, or find the part number that goes with it. It's very simple. If you have a system that won't start, replace that, and that should take care of it. If it doesn't take care of it, if you replace that and the fan still won't start, well, then you probably need a new fan motor. Again, it can be replaced. You can do it. You just need to find the exact same fan. The easiest way to do that, everything has a part number on it. Just got to find it and then do it. Again, make sure your power is turned off. If your compressor is not starting and you replace the capacitor and it still won't start, you're going to need to call a technician. At that point, you might need a new air conditioner. But call a technician. There are kits that they can install called a hard start kit that might get you through for a few more years. Well, that being said, that's going to wrap up today's video on HVAC, air conditioning service, whatever you want to call it. If you like this video, please consider subscribing to the channel. If this video helped you, please comment, give me a thumbs up. Comment if it did help you. I'm really curious. If you have questions, you don't understand something, put it in the comments. I'll do my best to get back and answer any comment I can get to. But with that being said, I hope it helps somebody. Let me know. Thanks for watching, guys. Appreciate it. We'll see you on the next one.